Hello everybody. Today we will be going over a derivatives problem at the IB Math AI SL level. So we have a cement silo made of steel that consists of a cylinder with height h and radius r and the cone at the bottom of the cylinder's base. The total surface area of the cement silo is given by blah, right? Where r is the radius of the cylinder in meters. Units meters, always notice the units for when you will answer. The silo is designed such that the total cost for the steel used is minimized. This is the same as minimizing the total surface area of the silo. Perfect. Then they tell us to find this. See? Now, this is a very fancy way to also express this, which probably seems much more familiar. See? Essentially, this is just a derivative, right? So it's going to be the derivative of, this is how we read it, derivative of function a in respect to r. See? So this function, we're going to do the derivative of it in respects to r. So we need to focus on r in this scenario. Now, which derivative are we doing? There's a couple you may have heard of, the multiplication one, the log one. At the SL level, we only care about the exponent one. See? Now, before we look into the example right here, I think it's important to look at general scenarios so we see what the heck is going on. The derivative formula, whatever you want to call it, see, for exponents is up here. This is actually in your formula booklet. As you can see, the intuitive way to perceive it is the following. You take whatever's on top, you plop it down in front, so it's multiplying whatever's in front, right, this n, and you do -1 to it, as we can see up here. So the exponent multiplies on whatever it's on the bottom, and you do -1 to the exponent. So how would this one look here? I'll do this one, you do the next one. This one would be 4 times 2, x, 2 minus 1, 8x to the power of 1, just 8x. See? So that would be the derivative in this scenario. The next scenario, take a moment, think about it. Pause the video if you'd like. Negative 3 times 4 times x to the power of 4 minus 1, negative 12x to the power of 3. See? Awesome. This last one is definitely more juicy, a little bit of a challenge. We're going to have 1/2 times 2 times x to the power of 2 minus 1. These cancel out. We end up with just x to the power of 1, or just x. See? All right, so that is the derivative of the exponent. In this scenario, we have a special case where the r is on the bottom. So we need to start thinking how that's going to work. But I wanted to show you these general cases just so that we know how the exponent works. See? Essentially, the question I'm trying to go for is, what is the exponent in this case? So I'm going to go ahead and rewrite, and this is something you should always do whenever you're facing a derivatives problem. If I rewrite the r to put it on top, I can have 48 pi r to the power of -1. And on the other side, it stays the same. I have not done the derivative yet. I am simply rewriting how my terms look like. If I want to put a term on the bottom, and when I say term, I'm talking about this r, for example, you need to put a negative on the exponent. See? Let me exemplify that a little bit more. If I have, say, 1 over x to the power of 3, this is the same as x to the power of -3. If I have x to the power of -2, this is the same as 1 over x squared. If these have constants next to it, such as 4 over here, right, this actually turns into that. If I have a 3 over here, this 3 would be up here. All right, now you know everything you need to know. So I rewrote my equation so that it looks like that, and now I will do the derivative in red. So the derivative of my function a in respects to r is going to look like this. This -1 is going to multiply the 48, right? So I'm going to have 48 times -1 times pi, because pi is also a number, r -1 minus 1, plus 3 times 2, right? So I have 3 times 2 times pi times r to the power of 2 minus 1. This first term is going to turn into -48 pi r to the power of -2 plus 3 times 2, 6 pi r. This is literally part A. That's it. There's nothing else you can do. If you want to get mega fancy, or how the formula, how the answer key has it, I think they put negative 48 pi, and then they put the r squared on the bottom. But that would just be rewriting your terms. I assure you, you have full credit just with leaving it as up here, as down here, it is the same idea. All right, so that's part A. All right, and now for part B, we have calculate the value of R that minimizes the total surface area of the silo. So I'll explain why later, but if you want to memorize this quickly, in order to minimize or maximize, see, in either case, you will always, always, always do whatever your derivative is equaling 0. I'll explain why at the end of the video. I strongly suggest that you stay for that, but in our interest of time, I will just go ahead and solve. See? So my dA over dr has to equal 0. My dA over dr we said was negative 48 pi. I'll put r squared on the bottom for now, plus 6 pi r equals 0. At this step, what I suggest to do is y1 on the left side, y2 on the right side, and you do what is called calc intersect with this. See, I have a video on it. I think it's the quickest way to solve this, and then you also avoid doing extra lines of math, which is always, something we'd rather avoid. See? So that's what I suggest doing at this point. If you don't like that version, the other version is, well, using a couple lines of math and your calculator, which I will show now. See? So first things first, we don't like that there's an r on both of my terms, so we want to try to combine them in some way. So I can actually divide by r on both sides, ¿cierto? And I end up with negative 48 pi divided by r cubed plus 6 pi equals 0. Now, I'm going to send this guy over there, ¿cierto? By adding. So we're going to end up with 6 pi equals 48 pi divided by r cubed. We're going to divide by pi for now, so I get rid of these guys. Pretty easy. Now, we're also going to divide by 6, ¿cierto? So 1 over 6 onto both sides. And we end up with 1 on the left side equals 8 divided by r cubed. Cross multiply, there's a over 1 over here. We end up with r cubed equals 8. At this point, since we have a 3 in the exponent, ¿cierto? We actually have to do a square root, but it's a fancier square root that's going to look like this. It's actually r equals square root of 8 with a 3 right outside. And r is going to equal 2. See? Now, this step right here, we can do it on our calculator. You actually just have to go, at least with the TI-84, you go to math right below alpha. On the fourth one, we have the same symbol that I just worked with. We put 8 inside. Bada bim, bada boom, we get 2. Don't forget the units. 2 would be meters. And so that is part B. Now I will explain why we equaled to 0 in the first place, which I think is very important to go over. See? So, the main idea is the following. Whenever you have f of x, which is like your normal one, ¿cierto? This is going to help you get a set of points, right? So you plug in 1, you get 2, you plug in 2, you get 3. You're basically making a sets of points, see? The moment that you have the derivative of this, right? This does give you like a set of points, but now this whole thing on the left side is actually slope. This is actually slope, right? And so when we equaled to 0, we were equaling our slope to 0. Now, why do we want to equal our slope to 0 in this case? Because we are dealing with a quadratic. Because there's a squared right here, ¿cierto? And so the fact that it's a quadratic means that my graph, sorry, I don't have a lot of space, but my graph is going to look something like this on the bottom left. Something like that, right? And so if we analyze our slopes here, see, the slope on this point right there is going to be, I don't know, negative 4, right? The slope on this point over there is probably going to be, making it up, maybe 7. Where's my slope 0? Aha! My slope is 0 on my vertex. In this case, my minimum. Look at that. That's why we equal the slope to 0, because in a quadratic, it will always give you the vertex. Now, you don't know if that vertex is a minimum or maximum, which is why I gave you the rule of thumb of always equaling it to 0. See? So whether they ask for minimum or maximum, you always equal the slope to 0. If we were to have a graph with a maximum, ¿cierto? The science is the same. I mean, this slope right here is, I don't know, 3, ¿cierto? This slope right here is, I don't know, -2. Where does it equal 0? At the maximum. At the maximum. So that is why we always equal our slope to 0. Maybe this helps you remember it more. I think it's important. But in the interest of time, I can also just give you the rule of thumb and you can forget about it and enjoy life. See? All right. I hope it helped. I'll see you around. Take it easy. Oh, also, my old math studies videos are mega similar to how Math AI does it nowadays. So I strongly suggest, especially for derivatives, to looking at them because it'll help as well. See? All right. Ciao, ciao.